Okay, hello everyone. My name is Gabriel Chung and I'm here with my advanced setting analysis video. So to start things off, this is my malware that I'm going to be analyzing now. It's the Google Adobe Flash Player. And to start things off, we are supposed to use IDEA Pro to do our analysis. However, we did encounter an error with IDEA Pro, and yeah, this is the error. We cannot set the target processor type CLI. We are unable to resolve this issue, and hence we decided to rely on OllyDbg to do our advanced setting analysis instead. So let me just run my file in OllyDbg. Open, go, okay, run. Okay, great. So at first glance we can see that it is pretty hard to determine where the entry point of the code is. So this is where PEID comes into play. So what we're going to do with PEID is that we're going to use one of the plugins from PEID. I believe it is called eCrab OED Viewer. This one, eCrab OAP Verify, yes. So a window pops up already. And the plugin returned an error. It states that OAP not found. This means that the entry point of the program cannot be easily found. So what I'm going to do now is actually try to analyze and break down bits and pieces of the code, separate bits and pieces of the code, and try and piece them together to get a better idea of the picture, better idea of the malware. So to start things off, let's go to this expression. Okay, so as we can see above, the malware is initializing a string of data, EAX, into the stack. You can see it has been pushed into the stack, and right over here, the malware follows up with scanning the initialized string for the last character in the string, and in this case, the character we'll be finding is S. So once that is done, the malware will perform a white character case insensitive comparison of the strings over here. As you can see, they are testing EAX with EAX. Over here as well, they're testing EAX with EAX, and that the EAX they are talking about is the one that is pushed in the stack, the string that was initialized. Over here, EAX. Okay, so next, for our second function, what we have is somewhat of a information retrieving function using buffers. So to start things off, this command getConsole output CP is a function that retrieves the output code page used by the console associated with the calling process, which means this retrieves the information that was outputted by the console. So what you can see here following that in the getLocalInfo function is that a buffer is being pushed into the stack. It is being sent to the computer, the host, to retrieve information. You can see that they push 10, which is like the buffer size, and they push in EAX, EDI, ESI, which is the buffer info type, local ID, etc. So once that is done, we'll send in another buffer with the exact same stats, only now they'll push in 0b instead of EDI. This is because they want to retrieve the info type equals b from the host computer. So okay, now moving on to our third function, the create file function. So the file name is mountpointmanager, and the access permissions is read and write. So this file, it breaches the security and forcefully implants itself in the host computer with more commands that we will get to later. So its attributes is normal and the mode is open existing. As we move down a bit, we come to this device IO control command. So what it does is that it overlaps itself and it sends out buffer of buffer size 20, and it takes in data buffer from the main computer as well. So what IO control does, what pushing ESI into the stack does, is it sends a control code to inject this file into the computer, and as usual the buffers are retrieving information and data from the computer as well. Next, we're going to move on to our fourth function, which is, so basically what we see here is that a mutex here is created. This mutex goes by the name of the shim cache mutex, and it bypasses security. What it aims to do is that it aims to bypass security and take advantage of the host computer, as you can see over here. This coincides with what we have done in our dynamic analysis. It also shows that we have created a mutex, and yep. So right now, that is all for our presentation. What we can concur from the codes that we have analyzed so far is that the malware pushes in a lot of buffers and data and retrieves a lot of data from the host computer. It initializes a string that will be used in later parts, and lastly a mutex is created, which means that this program is highly dangerous. Thank you.